So let's start with the last part. Now we will run a simulation to access the results and save nice images from a macro. Because a simulation would be the next step after generating structures. And we will choose a flow simulation. And therefore select Predict, GeoDict, and from the pull-down menu, choose the first one, the Stokes-Brinkmann layer. Click Edit, so we can make sure that we have all the same settings. We load the Boolean default values again. So now here we can click yes, because the default constituent materials are the same that we have in the fiber structure, so it's no problem. Click OK. And click Run. Can close the result viewer for the moment. And we go to the session macro again by clicking Macro, Session Macro. And now here we can also see that the executing of a macro and very macro are also Python commands that can save to a macro. So you can also run a macro from a macro. But we only want to have now the GeoDict command. But we don't want to have a new macro because for the flow simulation we always need a structure loaded in the user interface. And we want to run it on the different fiber structures. So we want to append it in the end of our macro. Therefore we highlight it, and now we click on Copy to Clipboard, because we want to copy the command in the clipboard so that we can append it to our Workshop 3 macro. So click Copy to Clipboard, go back to our Workshop 3 macro, and we will save it again under a new name. Now the Workshop 4. So again, make sure that you save the macro in your project folder and as a Python file. Click Save. And then scroll right in the back of your macro. And by right-click and clicking Paste or Ctrl-V, we can paste it. Now we see here the GeoDict command. And here in the beginning of the dictionary, we have the key result file name. And now, of course, we want to change the result file name right in the beginning. So write an F in front of it. And here add the variables again. GDSVP, closing curly bracket, underscore, opening curly bracket, GDFD, for the fiber diameter, closing curly bracket. And now we can also change the description again. So scroll up in the beginning, because now we also run a flow simulation. And we can click on Save. We'll go back to the macro execution control, click Refresh, highlight the Workshop 4. And now we can also see here in the preview that we have not only the fiber geo structure, that we don't only create fiber structure, but that we also have a flow simulation. And here we can see the line that we added to this description. Click on Parameters and enter again 10, 40, 70 for the solid volume percentage, and 1 E-5, 2 E-5, and 3 E-5 for the fiber diameter, and choose solid volume percentage from the pull-down menu. Click OK, and click Run. So now, of course, the fiber structures we generated before, so we can click Override, and now the flow simulation is done. Second fiber structure, you can click Override again. Again, the flow variability is solved. Click Override again. And the last simulation. If we now go back to our project folder, we can see here now the 3 result files for the flow simulation with the result files that belong to them. So now we can close the session macro, and we can load a result file, not only with file and open results, but also with clicking here the result file and per drag and drop load it here in the result viewer. Under the so here all the results are stored. We can see here the a nice report of our results. We are interested in the permeability value here in the permeability tensor. We only computed flow in z direction, so only the last column is only the last column has values. So here we need the bottom right value in the third column and the third row. And all these result values are stored here in the result map. And this is what we need to access them from the macro. We have to know it's in the result map, and then we have to know the right key here on the left. So we search here for the value that we want, and can see here we need the key permeability 33. So with this knowledge, we go back to the macro, and now we save it as workshop 5. Click Save. First, we could change the description. And returns permeability. Maybe here change the end to comma. And right in the beginning, we add the line import string map. This imports the Python module string map, and that allows us to access map files like the GDR file. I think we can scroll after the flow simulation step, and we will store the GDR file in the variable, which we call GDR. And here we need the Python module string map, and there we need the command path GDR. And here in the braces, we have to add the result file name, which we find here in the beginning of the dictionary for the flow simulation. You can simply copy it. And insert it here inside the braces. So now we don't want to have the whole result file, we only want to have the permeability value. So we will call it perm. And to access the value, accessing the values works the same as with dictionaries. So we can write GDR and then use square brackets and the right key as a string, which would be result map. And then we need a column because now we are in the result map, and there we need the permeability 33 value. And now we can output it with the API function gd msgbox. And we can click Save. Go back to the macro execution control, click Refresh again, select the workshop 5, And now here we have no preview anymore because we have now some Python syntax which is not part of the GeoDict commands. So click parameters and enter again 10, 40, 70 for solid volume percentage, and 1e minus 5, 2e minus 5, and 3e minus 5 for fiber diameter, and select solid volume percentage from the pull-down menu. Click OK. So click Run. Now we have to override the fiber structures and flow simulation step because we've run all before. Here we have the first message box for the fiber structure with 10% solid volume percentage and 10 micrometer fiber diameter. We have a variability of 3.1 e minus 11 square meters. Click OK. Now, of course, we have to override the second fiber structure and the second flow simulation. And then we have the variability result for the fiber structure with 40% solid volume percentage and 20 micrometer fiber diameter. Click OK. And we have the last fiber structure and the last flow simulation. And the last permeability value for the solid volume percentage of 70 and the 30 micrometer fiber diameter. Click OK again. And this way, any value from the result map can be accessed in the same way. You only have to need to know the right key and the right maps. You can not only access the result map, but also the input map or the log map. So now, in the last step, we also want to visualize our results and save nice images from our workshop macro. Therefore, we load one of the floating result files, here again here in the result viewer, and we will move to the flow visualization tab and click load. And here in the opening dialog, we can click OK because all the settings are fine. When we get to the visualization area, we can collapse the console again because then we have more space here in the visualization area. And now we see the fiber structure with the volume field. It's the structure with the 10% solid volume percentage. Here in our workshop macro in our workshop we only want to visualize the streamlines, so we can uncheck here the volume field. Now only the structure is displayed, and then we check the streamlines tab, and then we see here the nice streamlines. So we don't want the fibers to steal the highlight from the streamlines. So we change the colors by clicking here Settings, Color and Visibility Settings, and here now we see in the material legend that we have the material IDs 0, 1, 2, and 3 in our structure, and here the 0 is air and is invisible, as we can also see here that the checkbox is unchecked. But we have to change the colors for the 3 glass materials, which would here be 1, 2, and 3. So the 2 fiber types and the overlap in between. Therefore, we click here on the color button and choose gray, for example, for all 3 of them. So now we can't differentiate between the fiber types anymore, but we can see the streamlines better. Click Close. So the visualization would even be better if we wouldn't have the single voxels anymore, because GeoDict is a voxel-based program. The structures consist of voxels, but we can also visualize it by moving to the Structure tab, and for Structure mode, choose Smooth Renderer. And then you can see here the surface is smooth. That looks much nicer for visualizations. And then you can turn the structure as you want to, so it has a nice camera angle, wherever you like it best. And then we save a picture, click File, Save Image As, and we select Preset, and then the 4:3 would be fine in this case. You can also see a preview here, how it will look in the end. Click OK. And choose, for example, Streamlines as a name for our image. Click Save. And now an image of this structure with the streamlines is saved. And to record it to the macro, click Macro, Session Macro. Now we will need 3 of the commands, because we have to have a volume field. We have to have a volume field loaded, and we have to set the view status with all the things that we have set now, with the smooth renderer, for example, or the colors and the camera angle. And then, of course, we have to save the image. We can highlight all 3 of them by pressing and holding Control, and then click all of them. And then here, of course, we now want to append it to our macro again. So we will click Copy to Clipboard. Go back to our Workshop 5 macro. File, Save As. And now we'll save our last macro as Workshop 6. So again, make sure that you save the macro in your project folder and as a Python file. Click Save. And here, right after the message box for the permeability, we can paste the 3 commands. Again, we want to change the result file name with the varying solid volume percentage of firebar diameters. So here for file name in the save image dictionary, write an F in front of the string and add solid GDSVP inside the curly brackets and GDFD. We don't only have to change it here, we have also to change it in the loading of the volume field. Don't have to change anything here in the visualization settings. You can see here it's a very long dictionary because there are many visualization options. Can all be set and saved in the macro. And here we have the load volume field command. So here, again, we have to write an F in front. We only have to change here the folder name, because the flow field has the same name for each of the structures. But the result folder, of course, is different. We, instead of the 10, we insert the curly brackets and GD SVP. And instead of the 1 E-5 and curly brackets, we enter GDFD. So make sure that you have the same results folder name as before for the result files. As we have it here without the GDR. And then now we can add in the description that we also save an image. An image of the structure with streamlines. Then click Save. And go back to the macro execution control. Click Refresh. Highlight the workshop 6. You can see here again that we have now the description of the whole macro. Click Parameters. And for solid volume percentage, select 10, 40, 70. And for fiber diameter, select again 1e-5, 2e-5, 3e-5. And from the pull-down menu, select solid volume percentage. Click OK. And click Run. So now, of course, we have to overwrite the fiber structure and the flow simulation again. It's no problem. We have again the first permeability value. Again, overwrite the fiber structure and flow simulation. And the second permeability value. And the third fiber structure and the third simulation step. And the last message. Now if we go to our project folder, we have now 3 nice streamlined pictures. So here for the 10% solid volume percentage and the 10 micrometer fiber diameter, and here for the 40% solid volume percentage and the 20 micrometer fiber diameter, and the last one with the 70% solid volume percentage and 30 micrometer fiber diameter. And here you can see all three next to each other, and you can see that the flow is much slower here for the bigger solid volume percentage and bigger fiber diameters. Could also make the legends all the same and the corresponding colors the same, that you could compare it even better, but that you can learn all in the visualization user guide or the visualization workshop. So after showing you how to access simulation results and save images from Python macros, now in the end I want to briefly touch some advanced topics, and we will start with a nice FilterDict example. GeoDict comes with a simple application user interface to generate PowerPoint reports with GeoPython. This is very useful, for example, if similar parameter studies are done often. Then a Python macro can generate a unified report of the results to analyze them and show them in a nice way. This slide and the following slide are generated by a Python macro after another macro generated the corresponding parameter study. So here fiber structures with varying fiber diameter proportions were generated. The total solid volume percentage stays the same, but the proportional percentage of the two fiber types varies. So we start in the left with 100% thin fibers with 4 micrometer diameter and 0% of the thick fibers with 14 micrometer diameter. And then we go with to the right with more and more thick fibers and less thin fibers till we reach the 100% thick fibers and 0% thin fibers. And a FilterDict simulation was performed for each structure using a standard dust composition. The first part of the report generation was to save a nice image of each structure and two plots that we will see on the next slide. On the images, we see that the structures are clipped halfway so that the particles can be seen better. It's only for visualization. Structure is still there in total, but you can also only see half of the structure. So you can see with more and more thick fibers, more and more particles go through, as would be expected. And here we see the two plots that were generated with the macro, and on the second slide that was generated by a Python macro. And first, the first plot displays pressure drop versus the fraction of thick fibers. So for more thick fibers in the structure and less thin fibers, the pressure drop is lower than for very few thick fibers and many thin fibers. The second plot shows the filter efficiency versus the particle diameter. And we have one color for each of the different structures. So for it starts here in the bottom with 10% of thick fibers and 0% of the thin fibers. And we have higher efficiency for the for more thin fibers than for structure with more thin fibers than thick fibers, as we've already seen in the visualization. Finally, we briefly touch onto some advanced possibilities. First of all, you can also execute macros directly from the command line, including setting variable values, which is a powerful method to integrate GeoDict in your custom simulation and analysis pipelines. Furthermore, we have a set of GeoDict application program interface functions. We've already seen the GD run command and the GD MSG box, which could be some of the most important of these. But we also provide functions, for example, to directly access the voxel structure or simulation result fields, and for writing input geofilters for micro-CT images. You can find an overview of the API in the macro execution control. In the bottom, click GeoPy API Hub. And here you see a nice overview of all the function names and which arguments they need and what is the return value, and a short description. And you can also find you can find the automation user guide by clicking Hub. In the user guide, you find not only a description of the macro menu and the macro execution control, but many helpful examples for recording macros, adding variables, using the string map module, and for all GeoPython API commands. We also ship a set of popular open source Python libraries, which are installed into the Python interpreter within GeoDict. This includes fast MATLAB-style numerics with the module NumPy that could, for example, be applied to volume fields as the flow field seen before. And then we have the powerful plotting library matplotlib to plot results in a user-defined way. And of course, the Excel file generator XLSXwriter to create Excel files from a macro. Additionally, also the generation of PowerPoint reports from GeoDict results can be automated, that we've already seen on the slides before. Therefore, GeoDict ships a simplified web API to insert text, images, movies, and tables into a PowerPoint template. So I want to conclude the workshop by summarizing what we've shown you. Now, hopefully you can record and playback macros with GeoDict to automate common and repetitive tasks. And also you can add variables to macros and run parameter studies to optimize your materials. We showed how to access any GeoDict result from Python macro to summarize and compare simulation results. We hope that this will ultimately help to increase your productivity when working with GeoDict. Here you can find a helpful link to a great official Python tutorial. And thank you very much for your attention. Are any questions left?